All right, we're recording also. So, you said this one's 150 meters? Good point, that is way off. What is, I've got 2 feet by 1 5/10 of a foot. What would the area of that one be? 2 foot by 1 5/10 feet. What's its area going to be? What's it going to be, Tyler?
2.5.
2.5? I don't think so. Try again. What's it going to be, Jaslyn?
3 feet.
3 feet. Oh, and this should be 3 feet squared. What about 25 inches by 25 inches? What's the area of a rectangle? 25 by 25. What's it going to be there, Braden?
625 inches squared.
625 inches squared. Does anybody not know where these numbers are coming from? You're multiplying what there, Miss Kaylee? Good. Your width times its height. Good. So finding the area of a rectangle is pretty simple, right? It's nothing more than, this is length times, whoops, don't do that, Rakestraw. Get to using them. Length times width. Do you agree? Okay? Nothing more than that. So that's pretty simple for you. Do what?
That was base times height.
We also, it's the same thing as calling it base times height, or BH, same thing. Yes? Okay. You can call it length times width. You can call it base times height. You're talking about the same stuff, okay? So, now, this is a little bit different. This is a parallelogram. What do you know about finding the area of the parallelogram? Anybody know anything about that one? Maybe even from the IXL. What do you know, Tyler?
It's base times height times a half.
Base times height, now you said times 1/2. Are you sure about that one? Okay, let's think about, can I take, if this was a piece of paper, could I take it and could I squish it together to straighten it back up? Isn't a parallelogram the same thing as a rectangle?
Yeah.
Only it's just got a little bit of an angle to it. Okay, so how do we get the area of the rectangle? Chance?
Need base times height and then divide by 2.
On a rectangle, do you divide by 2?
No.
No. So it's nothing more than base times height. Okay, and that's going to equal your area. Okay. Now, the question would be, what was my question in my brain? It just went. Look at the first one. Number 1. What's the area of number 1 going to give you? What's its area? Esri. 24 centimeters squared. I agree. How do you know for sure where to count the height? How do you know for sure that that you've got the height of a parallelogram? What if I told you that, just for some crazy reason, what if I just put a measurement right there that said 15 centimeters? Which measurement would you use? Which measurement on that number 4 would you use if I told you that that angle piece was 15 centimeters? What's its area going to be? Mr. Cashton?
You should use it as because it's going to stretch down to the height, and that's within an angle, so it's pretty longer.
He's absolutely correct. You always use the height is where your right angle is being shown. That tells you it's straight up and down. The angle is going to be, it's just another measurement, but it doesn't affect the area. So on number 4, you would say 10 times 6 equals 60 centimeters squared. Does that make sense? Okay. Did I not collate those?
But I don't know. It only printed one down here, so I had here and because Carrie was on that.
Okay, sorry about that.
No, you're
All right, so number 2, what's the area of the parallelogram there in number 2? What's the area of that parallelogram, Cole? 9. Good. And it's 9 centimeters squared. Area is always whatever that measurement is squared, because it's a measurement times measurement, okay? So it's always squared, and that's how you know the difference between area versus perimeter. Could I calculate the perimeter of number 2? Do I have enough information to calculate that perimeter? No, I do not. Because perimeter is the sum of all the sides, right? I know this side as 3 centimeters, and that means this side up here is going to be 3 centimeters, but I don't know what the angle pieces are, so I can't find the perimeter of it, only the area. What's the area of number 3? Show me with your hands. When I say 1, 2, 3, show down, I want you, everybody, to show me with their hands what the area of number 3 is. Okay, I'm going to give you just a second. 1, 2, 3, show down. Show me the area of number 3. Okay, what is that area, Nicole, Monique? 8, good. 8 inches squared, okay? Miss Shelley is going to be handing you guys the notes on this so you can put the notes on your notes if you want to. And we can always go back to that too, okay? The key idea, this is what we've been doing. Just a little reminder, how do we get the area of a parallelogram? Base times height. How do you know this is a parallelogram? By definition, how do you know that's a parallelogram, Chance?
It has I forgot what they're called. It has an angle, but like it has like the 2 bottom ones.
Okay. When they're like this, we call them what kind of lines? Parallel lines. That's what you were looking for? You've got 2 pair of parallel lines in a parallelogram. The only thing different about the parallelogram and the square or the rectangle is the parallelogram, one pair of their parallel lines are at an angle. Okay, that's the only thing different. All right? Okay, I want you to calculate the area of A. Calculate the area of A. A. And everybody should have picked up their calculator earlier. If you haven't picked it up, you need to go get it. It's going to make your life easier. And right now, I want to know that you understand how to get the area of the parallelogram, not whether you multiply or divide. So I need you to calculate the area of that. You might use your calculator. So Monique, why don't you get up and go get your calculator, please, babe? What is the area of A? What's its area back there, Jordan? Are you sure about that? 168 meters squared? Did I do it wrong?
Yeah.
I probably did. Thank you. 168 meters squared. Jordan, how did you get it? Good. 14 times 12 equals 168 meters squared. Good. What about B? What about B? And do you know how to put 8.5 into your calculator? What are you going to have to do to be able to put 8.5 into that calculator? What are you going to have to do to it? What are you going to have to do to it, Chloe?
Make it a decimal.
Make it a decimal, good. And 1/2 equals what, decimal wise? 1/2 is how much of a decimal? 5/10, good, 0.5. All right, so what do you get when you calculate the 8 1/2 times 4? What's the area there? Jaslyn,
34 feet squared.
good, 34 feet squared. 8.5 times 4 is 34 feet squared. If you do not put the label on it, you will miss it. Otherwise, if you don't put the label there, it's just 34, and that doesn't answer that question. Okay? You have to have the label. Yes, sir, Mr. Jones.
I turned into a mixed number. So I did 8 times 2, but now I did 16 plus 1 is 17, 17 pounds. And then I did 8 to that 2, which would be 8 pounds. And I turned and then multiplied those. And I got 68, 2.
Okay. I don't think I'd go to that because I think you're going to have more chance of error. The more you manipulate the numbers and change them, the more chance of error is going to be for you. It's easier to take the 8 1/2 times 8.5. Okay? Just a little bit of advice there. Yes?
What if you do like other fractions that are bigger?
What if we get other fractions that are bigger than that? Well, let me see. I don't think you're going to at this point. If you do, a fraction is a division statement. So you could calculate that fraction that way. Okay? All right, what about number 1? 25 by 20. What is the area? Everybody is to do number 1 here. What is the area of number 1? Get number 1 done while we're waiting, you could go ahead and do number 2. Jaden, what is the area of number 1? 500 meters squared. Good job. 25 times 20. What about number 2? Number 2 is a little bit weird. It doesn't look the same as what we've been seeing. Does it make a difference in the calculation? What is the area of number 2? What's its area, Bub?
126 inches squared.
Good job. 126 inches squared. The fact that they gave us our straight edge, our height out here outside of that parallelogram doesn't change it at all. Always take it where the right angle is, okay? And number 3, what is our final area there? What's the final number? Josie, what do you get on number 3? Good, 615 yards squared. Good job, Josie. All right, let me see. Okay. Now, what if it wants to know the area of this parallelogram? It doesn't give us measurements, so we're going to have to find that ourselves, aren't we? So, what is the base of this parallelogram that we're looking at? What's its base, Emmy? 2. What is, and it's 2 units because I don't know what the measurements are, do I? Okay, what's the height of that parallelogram? What's the height of this parallelogram? Kaylee? 5. Kaylee says this is 5, so I'm actually looking at my height right there. 1, 2, 3, 4, I agree. So I've got 5 units. So what's the area of that parallelogram? What's its area? Roper? 10 units squared. Okay? I don't know what kind of units they are, and it doesn't matter. It's just the fact it's 10 units, okay? Okay, do this one on your own. Everybody do this one on their own.
It's 12. Be quiet.
Good. Good.
I was at 6 years. I thought the song was cool.
Good. You gotta do it. It's not acceptable. How many units price? 1, 2, 3, 4. Okay, so that's 4. How many units tall? Height. Going up. How many units? Okay, yeah. So what's its area?
They always say that.
12 what? We call these units 12U squared. What class? What is the area of this parallelogram class? 12 units squared. Now, some people say, well, how do I know that's true? If you had to count these units, that area means it's the space inside, right? The space inside the shape. So I've got 1, 2, 3, 4, 5, 6 full units. Do you agree? Okay. And then you just kind of look here and you find, see this little piece right here that's missing? And you've got a little bit extra there. Do you agree? So that's going to give me a 7th unit. I got a little piece here. And where's my other little? A little piece off there, so that's 8. I've got a half here and a half down above the 2. Not quite. This one and this one are going to match though. So that's 9. And then you've got this piece and this one, that's 10. And then you got this little piece here and this piece is 11. And these two, this one and this one together equals 12. Do we count the 12 units? It's proof. It's what's inside, okay? Area is used when you want to paint a room. It's important if you need to paint a room. Let's go to here. Yeah, that's one I want. Now, this one's a little bit tricky, so you have to read and follow what it's wanting. You make a photo prop for a school fair, okay? You cut a 10-inch square out of the parallelogram shaped piece of wood. What is the area of the prop? What's the area of the photo prop? How am I going to do that? How am I going to do it? Tyler?
8 times 4. Multiply 32.
Okay.
Times 12.
Now, why would I multiply the 32 times 12? Ah, he says I got to multiply it by 12 because that gives you how much? Good.
Where does he get the 12?
Okay.
There's 12 inches in a foot.
There's 12 inches in a foot. Notice this is in feet, and the square that they took out was in inches. And I can't subtract inches from feet without converting it to the same type of measurement. Okay? And then you said do what? You are so close. But would I subtract 10 inches from it? No, why not, Mr. Jones?
Because every side, there's 4 sides, so it'll be 10 times 7 would be 100, so you have 384 minus 100.
Because this piece is 100 inches square. Good job. Could I leave it like that if I wanted to? Sure I could. Or I can convert it back to feet. You agree? Yes, sir. Question?
Well, you said that you would do like instead of the x, because that would be an integration.
Yeah. I know, but I don't have an algebraic equation, so I'm good. But yeah. What?
Said it was a 10-inch square.
A 10-inch square means the square is, and see the arrows there? It means that's now, what do we know about a square? All 4 sides are the same, right? And so if I have a square, all 4 sides are 10 inches. Does that make sense? All right. Class is pretty much over. I'm going to give you your assignment. And I don't think it's one that you're going to struggle with. I want you to get your math practice journal. It's going to be page 80. Get it out and take a look at it, because I want to make sure that you have everything you need.
Page 80.
Page 80. Okay, it's going to be Math Practice Journal, page 80. And if you got it out to where you can look at it, 2 of those, look at number 3 and 4. 3 and 4 are just like the one we just did. The only difference is on 3 and 4, none of the measurements are different, so you don't have to convert measurements. Okay? But it's exactly like the last example we did. And then you do have a couple of parts of story problems. So you got 6 problems there. And then I want you to do textbook page 157. 22 through 26 even. Okay? Are there any questions on what your assignment is?